Hi, welcome to this Corbettmaths video. In this video, we're going to look at the GCSE Further Maths topic of cubic graphs, and we're going to look at how to sketch cubic graphs. Because sketching cubic graphs is sometimes part of the big graphs question. So there's often in GCSE Further Maths that big graph question where you may need to find where a graph crosses the x-axis, the y-axis, then use calculus to find the coordinates of the turning point or points, and then you're asked sometimes then to sketch the graph, and sometimes that graph is a cubic graph. So to sketch a cubic graph, I usually follow 4 steps. Step number 1, I consider the shape. So like with quadratic graphs, where if the x squared is positive, it's a u-shaped parabola, and if the x squared term is negative, it's an n-shaped parabola. With a cubic graph is in the form y equals ax cubed plus bx squared plus cx plus d. Now the shape of the graph will depend on what value we have for a here, and also the presence of an x squared term and an x term. If it was just something in the form of y equals x cubed, the graph would be a simple cubic graph, and you'll recognize those from GCSE level, where the graph comes up, passes through the origin and curves up again. If it's something in the form of y equals perhaps negative x cubed, then what happens is the graph comes down, goes through the origin and comes down again, and you recognize both of those from GCSE level. And also if there's a value on the end, for instance plus 1, it would just be that graph then shift up 1 square, and perhaps if you had here minus 5, it would be the same graph but just move down 5 squares. However, a lot of the time in GCSE Further Maths we'll have more than just those simple cubic graphs. We'll have something in the form of perhaps something like this: y equals x cubed plus 4x squared minus 9x plus 1, where you may have all the terms or you may not have the number on the end. Sometimes it's just x cubed plus 4x squared minus 9x. And then this graph would look something like this, where it comes up, reaches a maximum point, comes down again, reaches a minimum point, and then goes up again. And then that's what a positive x cubed graph would look like. If it was negative, so for instance, if we had something like y equals minus x cubed plus 2x squared minus 9x plus 1, then this cubic graph would come down, reach a minimum point, go up again, reach a maximum point, and come down again. So it's useful to know that if the x cubed term is positive and you have x squared terms and x terms, what the graph would look like would be something like this, where you have a maximum point and then a minimum point, so it comes up and then down and then up again. And if you have a cubic where you've got a negative x cubed term and you've got your x squareds and your x terms and so on, it'll come down, reach a minimum point, come back up, reach a maximum point, and then come down again. So it's useful to know what those cubic graphs would look like. There's more complicated ones where you've got more than just the x cubed term. Okay, so that's how we would do part A, consider the shape. Part B, find where the graph crosses the x-axis. Well, to find where it crosses the x-axis, the height's equal to 0, so you'll let it equal 0. So whatever you have in terms of the equation of the graph, you'll let the y equal 0, so it'll be 0 equals, and then whatever it is. Now, sometimes in the question it'll be factorized for you, which is fantastic. Alternatively, you might find that it's a nice one to factorize where you can take an x out and then factorize the quadratic that's left. So to find where it crosses the x-axis, you let y equal 0, and then you find where it crosses the x-axis by solving that equation. To find where it crosses the y-axis, then what you would do is you'd let x equal 0, so you just substitute in x equals 0 and find where it crosses the y-axis. And then finally, with these big graph questions, you may also need to find the coordinates of the turning points. Now to find the coordinates of the turning points, that'll just be part of the bigger question, where part A might be to find where it crosses the y-axis, part B might be to find where it crosses the x-axis, part C might then be to use calculus to find the coordinates of the turning point. So you'll differentiate it, so you find dy by dx and you'll let it equal 0, because you know that for those turning points, those minimum points or maximum points, the gradient's equal to 0. So you'll differentiate it and put it equal to 0. Hopefully when you differentiate it, you'll just get a quadratic, and then you can hopefully factorize that and find the values for x. And then once you find those x coordinates, you put them back in to find the y coordinates. And if you want more practice of that, I would recommend you go to Corbettmaths and you watch video number 643 and 646. And there's questions that involve finding those coordinates of turning points. But in this video, I'm going to focus more on the general sketching cubic graphs. I'm going to focus on steps 1, 2, and 3 in this video. And if you want more practice of step 4, have a look at these videos. So let's have a look at our first question. Our first question, we've been asked to sketch y equals x minus 1, x minus 3, and x plus 2. So you may be given a cubic that is factorized, and that's quite nice. And you can tell it's a cubic because if you would expand the brackets and do x times x times x, you'd get x cubed. Okay, so you may be asked to sketch something that is factorized, and that's quite nice, because if I wanted to sketch something like this, well, let's follow the steps. Step number 1, consider its shape. So if we were to expand the brackets, you get a positive x cubed. It would be x times x times x, which is x cubed. So that means that this graph should look something like this, where it comes up, it reaches a maximum point, it comes down, and then it comes up again. So that would be the shape of this graph, where it comes up and then down and then up again. Okay, step number 2, find where the graph crosses the x-axis. So I'm just going to sketch the x and y-axis. So here we've got the x-axis, and here we've got the y-axis, and we're going to label them x and y, so x and y. And let's find where this graph crosses the x-axis. So to find where it crosses the x-axis, let y equal 0. So let's let y equal 0, so 0 equals, and then we've got bracket x minus 1, x minus 3, and then x plus 2. So this is a nice question where it's already factorized for you. So now we can see, well, to make each bracket 0, x would be equal to 1, x would be equal to 3, and here x would be equal to negative 2. So that means that our solutions would be, if we solve this equation, x equals 1, or x equals 3, or x equals negative 2. So that means that this graph will cross the x-axis at 1, 0, it'll cross it at 3, 0, and it'll cross it at negative 2, 0. So that means that this cubic graph will cross, if we sketch that, it would be negative 2, 0, roughly there, 1, 0 will be there, and 3, 0 will be there. Now, considering the shape and considering the crosses of these points, we can actually do a bit of a sketch here, where it comes up, reaches a maximum point, comes down, and then comes back up again. So that would be our rough sketch. So we've done step 1, consider its shape. We've done step 2, find where it crosses the x-axis. Actually, let's label those coordinates. So we've got negative 2, 0 there. We've got here 1, 0, and here we've got 3, 0. And finally, our last step would be to find where it crosses the y-axis. And to find where it crosses the y-axis, you let x equal 0. So we're going to let x equals 0. So we're going to substitute 0 into this equation. So if we substitute 0 into this equation, we would have, well, instead of it being, I'm just going to write it out, x minus 1, x minus 3, and x plus 2. So if x equals 0, we're going to get our first bracket, 0 minus 1 would be minus 1. So we've got minus 1. Here we've got 0 minus 3, so it's going to be minus 3. And here we've got 0 plus 2, which is 2. So to find the value of y, we just need to do negative 1 times negative 3 times 2. And that's equal to negative 1 times negative 3 is 3 times 2 is 6. So that means that y is equal to 6. So that means it crosses the y-axis at 0. So because x is 0, 0 across, and 6 up. So 0, 6. And that's it. That's our sketch. Now, if we wanted to find the coordinates of the turning points, so the coordinates of the maximum point here and the minimum point here, so those two turning points, we would differentiate it. And part of this question, I would imagine, would be to expand these brackets. It'll say, as part of the big graphs question, expand x minus 1, x minus 3, and x plus 2 to help you. And then the next point would then say, use calculus to find the coordinates of the turning points of y equals x minus 1, x minus 3, and x plus 2. So you would expand the brackets, you would differentiate it, and then you would let it equal to 0. You then solve that equation and find the values for x. That'll tell you the x coordinate of that maximum point and the x coordinate of that minimum point. And then to find the y coordinates, you substitute those x coordinates back in here, and that'll tell you the y coordinates. And that's it. And if you want more practice out, remember there's those big graph questions on Corbettmaths, and there's the video on big graph questions as well. Also, I do some practice of this on the sketching quadratic graphs on Corbettmaths as well. Okay, let's look at our next question. Okay, so our next question, we've been asked to sketch y equals x plus 1, x minus 3, and 1 minus x. To sketch this, let's consider its shape. So if we were to expand these brackets, so let's look at the x terms. We've got x, x, and minus x. So x times x is x squared, times minus x would be minus x cubed. So if you expanded these brackets, we get minus x cubed. So that means it's a minus x cubed graph. So that means it's going to come down, reach a minimum point, come back up again, and then come down again. Okay, so that's the shape of this graph. It's going to come down, reach a minimum point, come back up, reach a maximum point, and then come down again. So that's the shape. Step number 2, let's find where it crosses the x-axis by letting y equal 0. And again, it's factorized. That's fantastic. So 0 equals bracket x plus 4, x minus 3, and 1 minus x. So if we want to find where this crosses the x-axis, we're going to solve this equation. So that means that x equals negative 4. Here, x would be equal to 3. And here, we've got 1 minus x. Well, what would x be to make this bracket 0? Well, x would be 1. So x equals 1. So that means that it crosses the x-axis at the points negative 4, 0, 3, 0, and 1, 0. So let's plot those points. Negative 4, 0 would be here somewhere. 1, 0 will be there somewhere, and 3, 0 will be there somewhere. And we know the graph has this shape, so it's going to come down. We can actually sketch it now. It comes down, comes back up again, comes down again, and then looks something like that. Okay, so that's the cubic graph. Let's label those points negative 4, 0. Here, this point was 1, 0, and this point was 3, 0. It's also useful to label where it crosses the y-axis. So to find where it crosses the y-axis, we're going to let x equal 0. So let x equal 0. So we had y equals x plus 4, x minus 3, and 1 minus x. So if x is equal to 0, we're going to have, we've got 0 plus 4, so that's 4. We've got 0 take away 3, so that's minus 3. And we've got 1 take away 0, which is 1. And let's multiply these. 4 times minus 3 is minus 12, times 1 is minus 12, so y would be equal to minus 12. So that means it crosses here at 0, minus 12. It's got a height of negative 12 there. And that's it. And if we wanted to find the coordinates of that minimum point and that maximum point, another part of the question probably would be to expand these three brackets. So you'd expand the brackets, you would then differentiate it, you'd let that equal 0, so you let dy by dx equal 0, you then solve that equation to find out values of x, which would be the x coordinates of the minimum point and the maximum point, and then you substitute them back into here to find the y coordinates. And that's it. Okay, let's have a look at our next question. So our next question, we've been asked to sketch y equals 2x plus 3, and then in brackets, x minus 4, close bracket squared. Now this question, we're going to follow the same steps as before, but it's quite interesting because we've got this bracket squared. This is called a repeated root. So whenever we solve it and you find where it crosses the x-axis, you're actually going to find you just get two solutions, unlike the 3. And because this one's squared, you're going to see it's a repeated root. And we'll talk about that in a second. Okay, so anyway, let's go through our steps. So if we were to expand these brackets, you'd have, well, you've got 2x plus 3, x minus 4, and then because squared, another x minus 4. It would actually be y equals 2x plus 3, and then x minus 4, and then another x minus 4. And if you were to expand those, you'd get 2x times x, which is 2x cubed. So that means that it's a 2x cubed. So that means that the x cubed term is positive. That means the graph will have this shape where it comes up, it reaches a maximum point, it then comes down again, reaches a minimum point, and then goes up again. So it'll have that shape because it's a positive x cubed graph. Okay, now let's find where the graph crosses the x-axis. So to find where this graph crosses the x-axis, we'll let y equal 0. So we're going to have 0 equals, and then brackets 2x plus 3, and then in brackets x minus 4 squared. So to solve this, we want to find when the brackets are equal to 0. Well, this bracket, it would be whenever x is equal to 4. And here it would be, now with these type of brackets, I like to write it equal 0. So I'm going to write 2x plus 3 equals 0. So when's the bracket equal to 0? I'm going to take away 3 from both sides to get the 2x equals negative 3. And then I'm going to divide by 2 to get the x equals minus 3 over 2. Or you could write x equals minus 1.5, whichever one you prefer, really. Okay, now you'll notice here that this time we've only got two solutions. Before we had our 3 different values. We had 3 different values for x here as well. Because we have this bracket squared, it actually means if we write out the 3 brackets, you'd have x equals minus 1.5, you'd have x equals 4, and another x equals 4. So this is what we call a repeated root. And in terms of the shape of the graph, this is the shape. So if we were to do this sketch, it's going to go up through here, through negative 1.5, reach a maximum point, it's going to come down, and then at this point, it's not going to go through the x-axis, that repeated root, it's going to touch it and come up. So that point there, 4, 0, it's actually going to be the coordinates of one of the turning points of this graph, the coordinates of the minimum point, and this was the point negative 1.5, 0. So when you have a repeated root, it doesn't cross the x-axis at that particular point. When it's a squared, it's going to touch it. It may be that it's a minimum point, like so. It may be that it's even a maximum point. It depends obviously on the shape of the graph. So because we knew from the shape of the graph that it has to come up and then down and up again, it meant that the one there had to be a minimum point. Also, in terms of these questions, remember these big graph questions, one of the parts will actually be to use calculus to find the coordinates of the turning point. You'll actually have done that before you sketch the graph, and you actually know that 4, 0 is a minimum point. You'll actually know that's the minimum point, so you'll know that the graph will have to then go back up there. Okay, so when you have a repeated root, so whenever it's a bracket squared, it'll mean that the graph touches the x-axis at that point. Okay, so that's fantastic. We've done our first 2 steps. We've considered the shape of the graph, and we've actually found where it crosses the x-axis, or where it meets the x-axis. It crosses the x-axis at negative 1.50 and touches it at 4, 0. Now let's find where it crosses the y-axis. So to find where it crosses the y-axis, we're going to let x equal 0. So when we let x equal 0, we're going to get y equals 2 times 0 is 0, plus 3 is 3, so our first bracket would be 3. In terms of our second bracket, if x is equal to 0, you're going to get 0 minus 4, which is negative 4, so negative 4. And then remember, we've got our squared. Now, our order of operations, we have to square before we multiply here. So we're going to do negative 4 squared, and negative 4 squared, negative 4 times negative 4 is 16. So we're going to get the y equals 3 times 16, just squaring the negative 4. And then 3 times 16 is 48. So that means that it crosses here, the y-axis at the point 0, 48. That's where it crosses the y-axis there. And that's it. Okay, let's look at our next question. So next question, we've been asked to sketch y equals x cubed minus 2x squared minus 3x. So this one's a little bit different than the ones we've looked at so far because this one hasn't been factorized. As you can see here, we've got x cubed minus 2x squared minus 3x. Now I've included this one because there's quite often questions like this in the big graph question where you may need to factorize this to begin with, and then you may need to find the coordinates of the turning points by using calculus, and then you're asked to sketch it. But it's quite useful to be able to know what this graph looks like anyway. So let's have a look at sketching this. So step one is to consider the shape. Well, it's positive x cubed, so it's going to come up and then down and then up again, like so. Okay, our next step would be then to find where it crosses the x-axis. So we're going to let y equal 0. So we're going to get the 0 equals x cubed minus 2x squared minus 3x. Now with GCSE Further Maths, it may be that it's factorized for you, or maybe that the question tells you where it crosses the x-axis, but I've seen questions like this where you have something like this and you need to solve it. So to solve this, what we're going to do is we're going to use basic factorization to begin with. So we're going to take an x out and then open up our brackets, and then if we divide all the terms by x, we'd have x squared minus 2x minus 3, just using basic factorization there. Now what we're going to do is we're now going to factorize this quadratic. So we're going to do bracket, 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 bracket. It's x squared, so we're going to put x's at the front of our brackets, and we want to find two numbers that will times together to be negative 3, and whenever you add them together you get negative 2. So I'm thinking negative 3 and 1, so negative 3 and 1, because negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. So that's fantastic. We've factorized that cubic. Now we can find our solutions. So we want to find when each of the brackets is equal to 0, or here x is 0, so x is equal to 0 will be one of the solutions. Here x will be equal to 3, and here x is equal to negative 1. So that means that this cubic will cross the x-axis at negative 1, 0 and 3. So it's going to cross here at negative 1, 0 and 3. And then if we draw the cubic, it would look something like this, because obviously we know its shape, so it's going to come up and then down and then up again. And that's what it would look like. And it crosses here at negative 1, 0. It crosses the origin here at 0, 0, so 0, 0. And then here it crosses the point 3, 0. And that's it. And also, if we want to find where it crosses the y-axis, we would let x equal 0. And if you let x equal 0, you're going to get 0 minus 0 minus 0, and that's equal to 0. And that makes sense here because it passed through the origin. And that's it. So that's our sketch of that cubic graph. Okay, and let's look at one last question. Okay, so last question, we've been asked to sketch y equals 2x cubed minus 11x squared plus 5x. And again, this one hasn't been factorized for us. So again, it's quite a nice one to factorize because they've all got x's in them. So you can use that basic factorization first, and then you can then solve it. Okay, now we want to sketch this. So let's consider its shape. It's 2x cubed. So the x cubed term is positive. So it's going to come up, reach a maximum point, come down, and then go up again. It's going to have that shape. Okay, now let's find where it crosses the x-axis. So we're going to let y equal 0. So we're going to let y equal 0. So we're going to have 0 equals 2x cubed minus 11x squared plus 5x, just letting the y equal 0. Okay, now let's solve this. So let's factorize the right-hand side. So we've got 0 equals. We're going to use basic factorization to begin with. So let's take the x out, and then that'll leave us with a quadratic. So if we take an x out, divide all the terms by x, so we'd get 2x squared minus 11x plus 5. Close brackets. Now we're left with a quadratic here. We can factorize that, hopefully. So we're going to get the 0 equals x and then bracket, 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 bracket. It's 2x squared, so we're going to go for 2x and an x. I'm just going to scroll down a little bit here. So here we're trying to find two numbers in the brackets that will times together to be 5, and then when we expand these brackets, we're going to get a minus 11x. So I'm thinking they're both going to have to be negative. And with it being negative 5, it's going to be a negative 1 and a negative 5. So I'm thinking if we put the 5 here, we'll have 2x times minus 5, that's minus 10x, and then a 1 there. Okay, and that's it. We'll factorize that quadratic. Okay, now let's find the values of x. So here, x would be equal to 0. Here, x would be equal to a half. Or remember, sometimes I like to let that bracket equal 0. So I'd write 2x minus 1 equals 0. So I'd have 2x equals 1, and then divide by 2x equals a half. Okay. So that's the solution there. And here, x would be equal to 5 to make that bracket 0. So that means that this cubic graph will cross the x-axis at 0, a half, and 5. So it's going to cross here at 0, the origin, a half, and 5. So, and remember, we know it has this shape here. So it's going to come up, and then down, and then up again. And it would look something like that. And that's what the graph would look like. And let's label the coordinates of our points. So we've got the origin, 0, 0. We've got the point here, a half, 0. And we've got this point here, which is 5, 0. And in terms of step 3, where it crosses the y-axis, we already know it passes through the origin. So we don't actually need to find the y-intercept because we know it's going to be 0 there. If we put 0 in, we'd get the y equals 0. So that means it can pass through the point 0, 0. And that's it. And that's it. So in terms of sketching cubic graphs, which is very useful for those big graph questions in the GCSE Further Maths paper, the steps that I would follow, well, often would be the steps in the question. The question would often have a part A, find where this cubic graph crosses the x-axis, find where it crosses the y-axis. It may have a part where you're asked to expand three brackets. It then asks you to use calculus to find the coordinates of the turning points. Then you find the coordinates of those turning points by using dy by dx equals 0. And then you're asked to sketch it. But whenever you're asked to sketch it, it can be useful to consider these 3 points, particularly here, to consider its shape. If the x cubed term is positive, it's generally going to look like that. If the x cubed term is negative, it's generally going to look like that. Now, there are exceptions in terms of those simple cubic graphs, but that's generally what it would look like. In terms of finding where it crosses the x-axis, you're going to let y equal 0, and that'll give you an equation and you solve that. There may be part of the question where you've already factorized the cubic, which would be handy for that as well. In terms of part 3, finding where it crosses the y-axis, you're then going to let x equal 0. And also find the coordinates of the turning points. You'll probably have done that as part of the question already. And if you want some extra help on those, you can watch those videos. And that's it. So I really hope you found this video useful. And if you have found it useful, please like it and please subscribe to my YouTube channel. Thank you. Cheers. Bye.